Hi, this is Jeline from the Honors Tutorial. Welcome back to part 2 of fractions as exponents under Mathematics 9. So this is example number 6, 4 raised to 1/3 times 4 raised to 1 over 6. Let's have the solution here, and then let's copy first the given, and that is 4 raised to 1/3 times 4 raised to 1 over 6. Same base here, same 4. Therefore, copy the base once only. So we have here 4. And then kindly add the exponents. That is 1/3 plus 1 over 6. Since we have here dissimilar fractions, because their denominators are not the same, let us use the butterfly method to solve for it. Let's have the fraction part first of the exponent. So we have here 1/3 plus 1 over 6. And then let's use the butterfly method. Then it will become 1 times 6, that's 6. 3 times 1, that's 3. 3 times 6, that's 18. So we have here 6, this 1, plus 3 over 18. And then let's continue solving here. So that is 6 plus 3, that's 9 over 18. Let's simplify this. How? Just think of a number that can divide the numerator and denominator at the same time without remainder. So let's divide this both sides by 9. 9 divided by 9 is 1. 18 divided by 9, that's 2. So we have here 1/2. This is for our exponent, okay? Now let's have the base that we have set aside earlier. So that is 4. So let's have 4 here raised to 1/2, which is the exponent earlier that we have solved. And then we have to change this into radicals. Our base, which is 4, should be our radicand. So we will place it here. And then let's write a radical symbol here. And then since your denominator is 2, so therefore your index will become 2. But since it is 2, we are not going to write it. It is invisible here. It is there, but we cannot see it. But it's 2. And then since it is 1, since this is 1, if we simplify 4 raised to 1, it will become 4 only. So square root of 4 is equal to 2. So 2 is the final answer for example number 6. Let us have another. We have here 5 raised to 1 over 5 times 5 raised to negative 1 over 5. So let's solve for it. Let's have our solution here. Copy the given. So that is 5 raised to 1 over 5 times 5 raised to negative 1 over 5. Same base, therefore copy the base. So we have here 5. And then add the exponents. So we have here 1 over 5 plus negative 1 over 5. Since the denominators is the same, we can operate on the numerator now. But let's change the sign of this because we have here positive and negative, and then it is equal to negative. So it will become 5 raised to 1 over 5 minus 1 over 5. So let's subtract because this is similar fractions. So we can easily subtract the numerator. So copy the base. 1 minus 1 is 0, and then copy the denominator. Let's simplify the fractional part here, which is the exponent. Remember, when your numerator is equal to 0, automatically your fraction is equal to 0. So this is equal to 5 raised to 0. And remember, any number that you raise to 0 is equal to 1. So therefore, 5 raised to 0 is 1. 1 is the answer for example number 7. Let's have another. Number 8. We have here 36 raised to 1 negative 1 over 7 times 36 raised to 1 over 3. So same process, since the base is the same, we will just copy the base and add the exponents. Let's write the solution here. Solution. So we have here 36 raised to negative 1 over 7 times 36 raised to 1 over 3. Copy the base, that's 36, and then copy 1 over 7 plus 1 over 3. Let's solve for the exponents first, and then let's set aside the base, which is 36. So we have here negative 1 over 7 plus 1 over 3. Let's use butterfly method. It is because the denominators are not the same, meaning this is a dissimilar fraction. So negative 1 times positive 3 is negative 3. 7 times 1 is 7. 7 times 3, that is 21. So we have here negative 3 plus 7 over 21. So negative 3 plus 7, that is equal to positive 4 over 21. Why is it positive 4? It is because when you combine a negative and a positive number, you have to subtract the numbers and copy the sign of the larger number. So in this case, the sign of the larger number is positive. So we have here positive 4. Now, our exponent is 4 over 21. Then, let's have now our base, which we set aside earlier. So that is 36 raised to 4 over 21. And then we have to change this into radicals because we still have a fraction part of the exponent. So remember, 36 will be your radicand here, and then write a radical sign here. Your denominator, which is 21, will be your index. So meaning we are going to place it here, and then this 4 will be placed here. It will become your exponent. So that is 36 raised to 4. So if we are going to simplify it, then it will become 21 root of 36 raised to 4. That's 36 times 36 times 36 times 36, and that is 1,679,616. But we cannot simplify it because there's no whole number that is 21 root of 1,679,616. So this is the answer already. Next, let's have another example. Number 9. We have here 49 raised to 2 over 5 divided by 49 raised to 1 half. So this is what you are going to do. Let's copy first the given. So that is 49 raised to 2 over 5 over 49 raised to 1 half. And then same base, kindly copy the base, so which is 49. And then since this is division, we have to subtract the exponents. So that is 2 over 5 minus 1 half. But as you can see here, they are dissimilar fractions because the denominators are not the same. So therefore, we have to use the butterfly method. Let's solve for the exponents first. So we have here 2 over 5 minus 1 half. So 2 times 2, that's 4. 5 times 1, that's 5. 5 times 2, that's 10. Then let's continue solving. So that is 4 minus 5 over 10. 4 minus 5, that is equal to negative 1 over 10. So this will be your exponent. So now we have here 49 raised to negative 1 over 10. So it will become, let's change this into a positive exponent. It will become 1 over 49 raised to 1 over 10. And then we have to change this into a radical. Then it will become 1 over, let's change this into exponential form. So it will become 7 raised to 2 raised to 1 over 10. And then let's simplify first the exponents that we have here. Let's solve for the denominator. So that is So that is 1 over 7 raised to 2 times 1 over 10. So that is 1 over 7. 2 times 1, that's 2. And then copy the denominator, which is 10. And then please simplify 2 over 10 because there's still a number that can divide 2 over 10 at the same time without remainder. So that is 1 over 7. And then let's divide this by 2. 2 divided by 2, that's 1. 10 divided by 2, that's 5. So we have here 7 raised to 1 over 5 in our denominator. Now let's change this into radicals. Then it will become 1 over fifth root of 7. Remember, 5 will be your index here. And then we have here 7 as the radicand and 1 as your exponent. But it is invisible. If it is 1, then you can make it as an invisible number, or just 7 raised to 1 is 7. So let me just have the left side of this equation to continue solving for it. And then we have to rationalize the denominator. So that is 1 over fifth root of 7 times fifth root of 7 raised to 4 over fifth root of 7 raised to 4. Why is it fifth root of 7 raised to 4? It is because we have here 7 raised to 1, fifth root of 7 raised to 1. For us to achieve an exponent of 5 here, for us to simplify, we lack 4 in our exponent. So therefore, um, we use 7 raised to 4 in multiplying for the numerator and the denominator to get the exponent of 5 later when we simplify. So let's continue. So 1 times fifth root of 7 raised to 4 is fifth root of 7 raised to 4. And then for our denominator, just multiply the exponent. So we have here fifth root of 7 raised to, add the exponents, s- 7 raised to 5. And then after that, since the exponent and the index are the same, we can just cancel this out. So we have here fifth root of 7 raised to 4 over 7. And then we are not yet done with this. We still need to simplify. Let us just cover the middle part for us to continue solving. So let's simplify 7 raised to 4. So that is fifth root of 7 times 7 times 7 times 7. That is 2,401 over 7. And that's it. This is the final answer for example number 1. If you have further questions or inquiries about this topic, kindly message the Honors Tutorials page. Thank you and God bless.